Welcome to the first of the stable marriage problems. Let's look at part A really quickly. Marty has the men propose while I have the women propose. So what does men proposing mean for the stable marriage algorithm? If you recall from class, men proposing um, means that you get a stable pairing at the end, which is male optimal. And at the same time, it is female pessimal. If I have the women propose, then I also get a stable pairing, but now everything's swapped. Females, it's female optimal and male pessimal. Now, if Marty and I come up with the same pairings, then what results is a pairing that is both male-female optimal and male and female pessimal. Obviously, it looks like there is only one possible pairing because it has to be the best for both genders and the worst for both genders. You can also do a little proof by contradiction. It's a little bit more rigorous than necessary here. Suppose there was another possible pairing P star that Marty and I come up with. Another possible pairing. Then obviously, without it being the same as P, it has to differ in some sort of optimality. So say case 1, it's more male optimal, then P loses this property. And case 2, if more female, if P star is more female optimal, then it loses this it loses this property again, and then case 3, case 4, so on. So clearly, there is only one stable pairing and one of the same pairings that Marty and I come up with. Let's move on to 5B, since 5A was really easy. Now, let's fill in these preferences with what the directions ask us to do. So, on day 1, right, so we're only concerned with Marty running the proposed reject. So, day 1, you have men proposing to women. So, man 1 proposes to A, and man 3 also proposes to A. Man 2 proposes to C. A prefers 1 over 3, so 3 gets rejected. Day 2, 1 gets held on a string, 2 gets held on a string, 3 looks for C. Now C decides C likes 2 more than 3, so 3 goes away. And now finally, A and C are both held on a string. 3 finally proposes to B, and everyone is matched up. And so this takes 3 days, right? So, sorry, this is day 1, day 2, and day 3, because we have 3 iterations and proposals. And the final pairing is 1A, 2C, 3B. Cool. Now let's move on to the next part. So now we're on part C of this problem. And so far we've been given, so for males, 1, 2, 3, we got A, B, C, C, B, A, C, B. And for females, we have A, B, C. We don't know these preferences. Remember, Marty assumed these preferences when we came in, and he happened to get a pairing that is correctly stable. So 1A, 2C, 3B. And now we want to find if we can come up with a different stable pairing given that we tweak some of the preferences. So first, we want to see what conditions we need for this pairing to be stable. So what do we already know? So Rooq pairs test. So we know that man 1 prefers A over B, man 2 hates A, and man 3 also has an A greater than B, but notice that A chose 1. If A preferred 3, then A3 would be a Rooq couple. So this is wrong. So this means that A must prefer 1 over 3, or else Marty's pairing is not stable. But it's given that it's stable. On the other hand, furthermore, you can use the same reasoning to show that C prefers 2 over 3. So 1 hates C, 2 has C over B, 3 has C over B. C chose 2, which implies that C must have 2 over 3 in its preferences, or in her preference. Okay, so good. Now we just need to make sure that A is paired to 1 and C is paired to 2. So when we construct these preferences with 1, 2, and 3 maintaining the same order, so suppose A goes to man 1 first, and then 2, and then 2, and then 3, while C goes to man 2 first, and then 1, and then 3, for instance. Then when we run the algorithm where the women propose, then on day 1, A goes to 1, B goes to 1, and C goes to 2, B gets rejected, right? So now on day 2, A is held on a string, C is held on a string, B goes to 2, B gets rejected, and then finally A, B, C, A goes to 1, B goes to 3, C goes to 2, and we end up with the same ordering as last time. So maybe there's something to this not being possible. Is it possible to have everyone paired with somebody different? Maybe not. So let's actually do a rigorous proof to show that it's actually not possible. So let me clear this for a moment and give you a moment to pause and copy everything down. Cool. So remember that we had 1A, 2C, 3B, and then we also had A must have 1 over 3 and C must have 2 over 3. Now, suppose, right, suppose there was a different ordering, then one of these have to be different. So let's focus on A first. So, for instance, suppose our new pairing has 3A, but this is a Rooq couple because A prefers 1, and 1 who's not with A prefers A. So 1A is Rook. And so this pairing is not possible. Now suppose new pairing has 2 and A. Again, we can use the same reasoning here to show that 1A is Rook. So 2 and A is not possible. So this shows you that 1A must be in the pairing. So, and if you follow a similar reasoning, then 2 and C must also be in the pairing. But I want to make this a bit different from the solution so that you can see how all of this works. Cool. And then finally, you have to decide between 2C, 3B and 2B, 3C, right? Now here, this is the original. So we have to be different from the original. But what we see here is that 2 prefers C over B, and C prefers 2 over 3. And this is established because this original pairing by Marty is stable. Marty's pairing is stable. So this means that 2 and C will be Rook, so this pairing cannot happen, and so we're left with 1A, 2C, 3B as the only possible pairing. So for this part, I'm not going to rewrite the whole question. You guys get the idea? In the process, we used a lot of contradiction, right? Suppose something, then we go to an R, we go to a minus, not R. So R is 1A is Rook, but then we realize that it's inside the pairing that we originally assumed to be stable. So that's where we hit our contradictions. Cool, so that is 5C.